Hey everyone. I'm Marty. This is Tim. We're from Wanyama. And before I start, I'd like to pay or acknowledge that we're on Noongar Whadjuk country and pay my respects to our elders, past, present, and emerging. I have what I call an accent. Some people call it a speech impediment. We're going to talk about open source drone mapping. We work, like the guy said, from Wanyama, which I found out today actually means it's a Nyama word for sea eagle, and it describes how sea eagle sees the world, like spatially very relevant to mapping. Yeah, we're a Western Australia and Indigenous owned and operated business. We're a provider of location intelligence and digital mapping solutions. We have a few projects on the go at the moment, usually around spatial stuff, Earth observation, SmartSat, a really cool one, Indigenous heritage 3D visualization, all about basically building a digital twin of country and making it a lot more relevant, a lot more comprehensible to elders. And one of our big projects at the moment is the Pilbara Cultural Land Management Project, or PCLMP. It's large scale, it's long term, and it's all geared towards training, educating, building equity for a lot of ranger groups up north in the Pilbara, enabling them to take control of data that they collect on country and retain that ownership. And I say it's a project, it's basically a program of works composed of maybe 7 projects, cultural economic land use assessments, earth observation, building a resource hub for knowledge capture and storage, drone training, mapping training, and development of a digital and long-term geospatial strategy for these 10 different ranger groups. And here's a few photographs of us up north. We had a recent training session up in Port Hedland last September, and some of the photographs. What's the big deal about that, and how does it relate to open source mapping? So currently, a lot of the groups up there are using drones for video, single photographs. They are getting photographs for promotional material, bit of land monitoring, and small-scale aerial mapping. And they kind of go up and they take like a single photograph or a single video, but in terms of making a baseline for kind of data capture and analysis, a single photograph really doesn't do much. But if they have a drone, they can send up a drone on a pre-programmed flight path, capture a lot of data, stitch it together in an orthomosaic, then use that for analysis, either in Google Earth Engine or whatever sort of GIS software you have. We did feel that this presentation was a little bit dry, so we threw in a few memes here and there to try and keep you guys on your toes. So the PCLMP project, Mapping for Country and Land Management. What we're focusing on today is the drone mapping aspect of it and the drone imagery processing. And the really good thing about it is you can collect these multiple site-specific orthomosaics, generated each year, 2 or 3 times a year. You're building your baseline, you can analyze it, and then detect change over time. You can identify illegal or unauthorized activity, and you can quickly scope planned activity and provide input to local state government stakeholders. And really importantly, the ownership of the data belongs to the groups and the rangers, and they can keep it contained, or they can upload it to data.wa.gov as to subscribers, or some sort of way of kind of monetizing it and keeping control of the data. So that's the drone mapping use case, but why open source? Again, we're working with ranger groups subject to different levels of funding. Some have lots of funding, some don't have very much at all. So the cheaper we can make it, the better. There are multiple paid solutions. There's Drone Deploy, Maps Made Easy, Pix4D, so many different ones. Some of the companies offer an all-in-one solution, some offer part solutions. Each have their own methodology, workflows, interfaces, and learning curves. And they're usually expensive and subscription-based, or there's usually some sort of impediment to make it more difficult for groups to kind of get involved. Enter Open Drone Map. We had a colleague, we were planning on doing drone training a while ago using a specific software, and one of our colleagues said, oh, hang on, this is really expensive, it's not sustainable for the groups. I found this really cool thing called Open Drone Map. Let's check it out. So we did. Oh, here we go. That's a belter. So from Open Drone Map, the main outcome we wanted was an easily accessible, easy to use image processing platform for the groups and the communities And all they had to do was fly the drone, capture imagery, and OpenDroneMap would do all the heavy lifting in terms of processing and analysis. And I'll pass you over to Tim, who's going to talk a bit more about the setup of OpenDroneMap.
Cool, thank you, Marty. So my name's Tim Cable. So I'm a Wilman Noongar man. So my Indigenous side of my family, they come from Narrogin, and they play a fair bit of footy out there, and I play myself. At Winyama, I am an IT consultant, but I wear many hats. In this particular project, because we wanted to start working with this open source software, OpenDroneMap, had to put on the solutions architect cap and get that working for our ranger groups. And I should quickly preface this as well, give you guys a bit of background on myself. I am not a geospatial person, so no curly questions at the end. But yeah, I actually started in IT support. So my journey, I did a bachelor's degree at Curtin. It was like a business degree in information systems and tech. It's like a business IT degree, a bit weird. And then made the journey to IT. So from there, my only knowledge of geospatial was that I would occasionally get calls from users saying, hey, how do I connect to the license server and, use ArcGIS Pro or something like that. So I'm like, okay, that's geospatial, I suppose. But obviously going across to Winyama and working with Marty and all the other guys there, come to learn quite a bit. So OpenDroneMap, I'll give you guys a bit of a brief overview, although I'm pretty sure plenty of you guys will have come across it or seen it at some stage if you're interested in open source software. So it's not just like one software solution, it's a collection. Yeah, it's up there on the slide. It's a collection of open source drone mapping software. So there's lots of ways to use it and interact with it. So ODM itself is like the brains of the operation. So before, you would have to use the command line and type in commands, basically specify, all right, here's where all my images are, do this operation. But if you think about if you're trying to train a group or if you're trying to introduce people to that kind of technology, the second they see that, you've lost them, So accessibility is a message I'm going to kind of harp on a lot throughout this presentation. And that was our mission, really, was how do we make OpenDroneMap accessible for these ranger groups, these Indigenous ranger groups, don't have too much funding, and they're kind of just learning their way and feeling their way through their GIS journey. And in the words of the OpenDroneMap organisation, OpenDroneMap is an ecosystem. So you see it there as well, they live by it, it's a collection. Talking about the install and setup a little bit. So OpenDroneMap, it's not available as that all-in-one desktop software. So it can be a bit difficult to work with for users who aren't accustomed to the command line. Luckily, and luckily for me, because we're humans, we're visual creatures, the web ODM flavour of OpenDroneMap gives you like a user interface that you can use. So you can install it, run it locally. It's not like ArcGIS Pro or QGIS and that it's a nice little application window that opens up. It basically serves a web server locally on your laptop and you can open the browser and use it. So if you think about it, that was one way we could have done it. We could have set this up for all the rangers, but I'll talk a bit why later as to why that's not a good idea. Yeah, just to kind of eliminate any confusion, the solution we're going to kind of showcase for you guys and talk the most to is WebODM. So not just OpenDroneMap collectively, but more so WebODM. Yeah, so here's the point I was going to get to. So you can install it locally on your personal computer or laptop, but you will be constrained by the resources of your personal computer or laptop. And this is pretty relevant to the other chats we just kind of heard where people were talking about Google Earth Engine. The fact that you can get all this imagery, you can chuck it into Google Earth Engine, it's going to do all this calculation, all this processing for you. That's using Google's resources. You don't have to worry about the computer you're using to do it. Similar kind of thing here, if you try to just run OpenDroneMap locally, I hope you've got a really big laptop. I don't see many laptops with 64 gigs of RAM going around. So that could be a really big problem if you're trying to process thousands of images, thousands of photos. And if you think about our rangers, they've got so much land to look after, it's probably just not going to be feasible. It's not going to be doable. So what do we do about it? So this is a little kind of graphic just talking about when you have OpenDroneMap or WebODM as we have it installed on the server, how it kind of works. So you're more or less constrained by the number of images you're trying to do, so the size of your data set. So if you had a really small, well, I don't want to say really small, but like a general laptop, you could probably handle about 100 images. If you wanted to do a couple hundred, 200 to 300, you're going to need a pretty decent laptop, about 16 gigs of RAM. This is going off, some guy wrote some really wonderful documentation for OpenDroneMap. and he's included in there, I guess, like a way to calculate what you'll need. He kind of just says increase RAM and disk space linearly. I'm sure it's more complex than that, but that's the best way to kind of demonstrate it in a graphic. And a couple quick notes. If you've got a CPU with more cores, it's going to do it faster, and a GPU or a graphics card has no impact on performance. So what does our WebODM look like? So this is a really basic infrastructure. So whenever I talk about ODM with the guys in the office and stuff like that, it can lead to a bit of confusion. So I've had to do a few diagrams, graphics, just to explain it a bit better. But this is like the end-to-end process for our rangers. So they'll go out to a site, they'll take their drone, they'll capture some imagery. That imagery is going to get stored locally on the drone's SD card. So the ranger's going to take it back to the office, they're going to upload it over the internet, and that's going to go to our WebODM server. Now, this stuff happening in the back end here is auto-scaling. I'll get to that a bit. I'll get to that in a bit because I've got a graphic that explains it a bit better. But basically the way to look at it is we've got this one server that's running ODM. What happens if multiple users, like multiple rangers, try to use it at the same time, try to do multiple processing jobs, like what's going to happen to our server? It's going to hit that RAM threshold and it's going to fail. One thing as well is the jobs are going to queue, so people will have to wait. So that wasn't really ideal for what we wanted to do, which is we wanted to have all our rangers, whenever they want, on demand, can just get their drone imagery processed. So the way this works is as they make a task, so as they upload their images, a new server gets spun up on demand and does the job for them. It drops it back into this bucket here, and then that goes back to the master server. So if you know anything about AWS Cloud, you might recognize some of those icons. Very basic. It's monolith in a way in that it's just EC2. And EC2 is just servers, really. Probably the simplest way I can explain it. So this talks a bit more about the auto-scaling. So some of you guys might have been thinking, okay, well, if you're spinning up a server, what if it's a really big job they're doing, a really big task? What if they've given you thousands of photos? What if they've given you a really small job? So just a couple photos, a handful, or up to 100. How are you going to manage that? Because if you're thinking about your compute resources that are doing the work, you want to do it efficiently. If you're spinning up the same kind of size server each time to do those jobs, it might be too big for the job and you're wasting money, or it might be too small and not be able to do it. So this just kind of talks a little bit how the auto-scaling works on the back end. Basically, it's going to see how many images. That's basically the main question that gets asked in terms of scaling. And it'll fall into a range. So to talk about the blocks, if it's under 250, it'll spin up this smaller server. And you can see I've put some little specs down there. So 2 virtual CPUs, 8 gigs of RAM. If it's 500 or more, it's going to go to this bigger server range, which is 4 virtual CPUs, 16 gigs of RAM, 320 gigs on that disk volume, and so on. And it kind of goes all the way up. There is obviously a threshold that you would hit if you tried to do a task that's too big. But for our rangers, we don't imagine that they're going to be doing any more than a couple hundred photos at a time per survey. So this is just a quick screenshot of what our of what the app actually looks like. So if you've never used ODM, this is what the user interface is like. So people can come on. You can see there's a few projects there. So you basically make projects, and a project has an amount of tasks that you make. You've got a little account sign in up the top. So it's not just one account, one master account. You can make different users. The setup that we've got is we've got one account for each ranger group. Ranger groups can be very flexible, and that rangers kind of come and go. So it wasn't really feasible to make a named account user, although that is best practice and definitely what I'd like to do. It just wasn't super fit for what we were using it for. And in terms of those processing nodes, it's probably better for me to go deeper on that, like out of this presentation. I'll be here for too long. But that's the grunt work. So you can see we've got 2 there. There's this node -ODM-1. That's our local servers processing node. Normally that's off and you can't see it because that's a set size. The IMW network is our auto-scaling solution. So if you log it to that processing node, it's going to go into that auto-scaling I was showing you guys before. So time for a quick tour. So I'll show you guys the website just to kind of show you how it works. I'll be very quick. So like I was showing you before, you've got a dashboard so you can make a project. So let's say I was doing some, you'd probably put a site name here. Let's just say Herdsman Lake, which is nice and local. You can create that. Then you select images, so nice and simple for rangers to use. They can jump in here. You're seeing my messy file structure at the moment, but I've got some demo photos here I should do from Bobby. So you can select all of those. You hit open. It's going to ask you, this is that processing node I was talking about before. So if you've got this set up a different way, maybe you've got dedicated servers of certain sizes you want to use, you can do that. This is where you choose it. So I would choose, let's just say the local node for now. And then this is really interesting. So although Marty was talking about that orthomosaic base map approach before, you can use this for 3D modeling as well. And I think you're going to show a bit of that. Yes. You can model buildings. You can see them all there. And this will actually change the algorithm that ODM uses to process your imagery. Because if you think about it, if you've taken images that aren't set for a 3D model, then ODM tries to go off and build a 3D model from it, it's going to have some trouble. And then there's a whole load of other options you can choose from here as well. And you can see it's a really long, extensive list. So lots of people have been working on this project for a while, and it's stacked with features. So you'd normally give your task a name. I'm just going to leave it, hit review, start processing. It'll upload photos and it just goes. And I don't need to have this browser open. This is happening on our server. Users can do that, upload it, forget it, come back later and get their output. So if you've used like other enterprise drone mapping solutions, maybe Drone Deploy or Pix4D, very similar, upload your photos, set and forget. That's how it goes. So just to end off my little section as well, and this just kind of goes back into that stuff I was talking about before. So getting a default installation of WebODM up and running is easy. So you saw our server there. You can make something really similar to that quite easily if you've just got a bit of server administration knowledge. It runs on Linux, although you can get it for Windows as well. Stuff like that uses Docker. And now with the cloud, it's easier than ever. Just spin up an instance. You don't have to go talk to your IT guys down in the back shadowy corner and ask them, hey, can we get our own server, our own computer to do this? You can just do it yourself. If you've got an account, that kind of thing. And yeah, once you start to look at the advanced features like auto-scaling and running ODM as a service like we were, things start to get a little bit complicated. And we have had some trouble with the auto-scaling that we're trying to work out. So you can see, I've had a whale of a time troubleshooting some of these things. And it even goes a bit back to what Russell was talking about before, with his talking about open source community. There is a community channel. They're super helpful, super friendly. And people are posting on there daily about their trials and tribulations with OpenDroneMap, and I've been there myself. So there are problems, but you can work through them with community. So the good news though is that, like I said before, if you're just running a default install of WebODM, using your own servers like local processing stuff, it works very well. It's nice and easy to get set up. And yeah, I think it's a great fit and a very affordable option. So for aspiring ODM server administrators, so if any of you guys think this looks like a great fit for your business, you're interested, that kind of thing, like I said before, cloud is a great entryway to get into, just starting up your server, having a play around, making a little sandbox. It's really, really good. Like I said, if you need help, there is a community forum, so you can create an account, ask questions, interact with them as well. And if you were, this is just a bit about pricing. If you were going to commit to processing drone imagery long term and wanted to use the cloud, you could take advantage of reserved instance plans. I'll talk about that offline if you want.